Welcome to Beta Online Learning. This is the video for the 12th standard CBSE Mathematics on the topic Differential Calculus. In this video, we are going to see the methods of differentiation, logarithmic differentiation. We're going to find the solution for a seemingly hard problem on logarithmic differentiation. Now let us see the problem. The problem definition is this. Here we are going to solve a seemingly hard problem which can be solved easily using the concepts of logarithmic differentiation and basic rules of differentiation. The question is, find the derivative of x power sine x plus sine x power cos x. This is a function which is the sum of two functions of x. And both are trigonometric functions. We'll use logarithmic differentiation to solve this problem. Let us see this concept. First, let us see the concept used in solving this problem. We combine the concepts of logarithmic differentiation and differentiation of implicit functions. We also use the basic product rule of differentiation, y is equal to uv, where u and v are functions of x. Then dy by dx is equal to u into dv by dx plus v into du by dx. Here is the problem definition. Find the derivative of x power sine x plus sine x whole raised to the power cos x. Let us see the solution. Now let us assume y is equal to this function, given function. Here y is a function of x, which is a sum of two functions of x. So let us split up the two functions separately. Like let y is equal to u plus v. Take it as equation 1. So where u, we'll take it as x power sine x, and v as sine x whole raised to the power cos x. You have to differentiate. Now let us differentiate the sum of the two functions as dy by dx. Let us differentiate equation 1 with respect to x. Dy by dx is equal to simply du by dx plus dv by dx. Let us consider this as equation number 2. Let's start differentiating u and v separately. First, let us see u. U is equal to x power sine x. So, use logarithmic differentiation by taking logarithms on both sides. We take logarithms on both sides, we get log u is equal to, actually it is log of x power sine x. We use the power rule of logarithms to bring this sine x to the multiplication. So, it becomes sine x log x. Then, we differentiate both sides with respect to x using the implicit differentiation and chain rule. Implicitly, we take u as a function of x. So, when you differentiate log u, you'll get 1 by u into, again, it's differentiated with respect to x. So, since u is a function of x, we have to multiply by du by dx. That is equal to the right-hand side. So, differentiate the right-hand side, we get a product of two functions of x. So, we use the product rule. What is the product rule here? Sin x into log x. If you differentiate, you get 1 by x plus cos x. Sin x, when you differentiate, you get cos x, and log x, you keep it as it is. So a sum of product becomes a sum of two terms. As we move on, we simplify and finding the derivatives. We do the du by dx to one side. So du by dx is equal to, keep du by dx on one side, and then we just go back to this. So we'll multiply this u on the right hand side, sin x by x plus cos x log x. So du by dx is equal to u is sin x power sin x. So we can substitute for that and then the remaining terms inside the bracket. Now let us see the v. V is equal to sin x whole power cos x. Again, differentiating, taking logarithms on both sides first. Before differentiating, we have to take logarithms on both sides. So log, because we have an exponent on the other right-hand side. So log v is equal to, again, log sin x whole raised to the power cos x. We use the power rule of logarithms. Bring the cos x to the multiplication side to multiply this by log of sin x. So cos x into log sin x. Now differentiating both sides with respect to x again. We get implicit again. So 1 by v, because log v, when you differentiate, you'll get 1 by v into v with respect to x. dv by dx is equal to cos x using the product rule. So it's a product of two functions. So cos x as it is. Log of sin x is actually logarithmic function chain rule. 1 by sin x. We first differentiate log of sin x as 1 by sin x. And then sin x with respect to x is giving cos x. So we multiply by cos x plus the next part. Differentiate cos x, we get minus sin x. And log of sin x, we keep it as it is. So this is the further moving on, we multiply this by v on the other side. So dv by dx, we want only dv by dx. So dv by dx on the left-hand side is equal to v into cos squared x, because cos x into cos x, here we get cos x into cos x. So cos squared x by sin x. As we move on, then minus sin x log x. This part. This is equal to sin x. So now v is substituted for sin x power cos x into cos squared x by sin x minus sin x log x. So here dv by dx will be the final one after simplification will be dv by dx is equal to sin x whole raised to the power cos x within brackets into within brackets you get cos squared x by sin x minus sin x log x. Substituting the values of du by dx and dv by dx in equation 2, we get the final answer. And this is the final answer. So dy by dx is equal to, this part will come down here as the first du by dx. X power sin x into sin x by x plus cos x log x within brackets. This is the first part plus the sum of the other. The second part will be this part, dv by dx. Sin x whole raised to the power cos x into cos squared x by sin x minus sin x log x. And that's the final simplified result. Thanks for watching this video. Have a great day.